In this tutorial, you're going to learn how to find the maximum or the minimum value in a graph. So let's say, for example, you have a quadratic function in your y equals x squared minus x minus 6, and after you've graphed it, you see here that we have a parabola and it clearly has a minimum. And we want to calculate what that minimum value is. So we have to bring up the calculate menu. Now to do this, we are going to have to hit second and then trace, and that brings us the calculate menu. Now, since we know that we're looking for a minimum value in this graph, I'm going to scroll down to minimum. You can also press 3 if you prefer. I'm going to hit enter. And now this is going to ask you for a left boundary and then a right boundary. What this means is it needs to know which maximum or minimum value you're looking for. Now we know there's only one minimum value in this particular graph, but the calculator doesn't know that. So we're going to give it a left boundary. That means I want to make sure I'm on the left of the minimum value that I want the calculator to find for me. So it doesn't matter how far you are as long as you are sure you are to the left of the minimum value. I'm going to hit enter. And then now it's going to ask you for a right boundary. So now you want to make sure you move this far enough that you know that you are definitely past the minimum value. You're definitely to the right of it. I'm going to hit enter. And now it says guess, and you're going to hit enter one more time. And it's going to find that minimum value, and it looks like that minimum value is going to be at the point 1/2, comma, negative 6.25. So the minimum y value is negative 6.25, and it happens when x is equal to 1/2. Now let's say that you're trying to find a maximum value. So for example, here in our y2, we have a negative x squared plus 4x plus 5. Now in this case, we can see from our graph that this definitely has a maximum value. We'll do practically the same thing, except that when we bring up the calculate menu, so second, trace, we want it to find the maximum value, not the minimum value. So I'm going to make sure that I'm finding the maximum here. It will do the same thing, ask for a left boundary and ask for a right boundary. So I'm definitely to the left of it right now, so I'm going to hit enter. And then it's asking for the right boundary now, so I'm going to move until I'm definitely past that maximum value. I'll hit enter again. And it says guess, hit enter one more time, and we get that this maximum value happens at 2, 9. So we know the maximum value is 9, and it happens when x equals 2. All right, now let's say that we have this graph x cubed plus 2x squared minus 5. Now looking at this graph, we know we don't have a quadratic, so we don't have a parabola. Now notice here we actually have a maximum and a minimum value. We call these the local max and local min. Now to find each of these, we'll have to find them separately, and we'll have to be sure that we are, in fact, telling the calculator which value to look for, whether it's the maximum or minimum. Remember, these are local max and local mins. So let's start by calculating the minimum value. So I'm going to hit second, trace. I want to calculate the minimum value. And we know the minimum value is somewhere around here, so I'm going to move to the left, make sure I'm definitely to the left of that minimum. I'm going to hit enter. I'm going to move to the right until I'm definitely past it, hit enter one more time, and I get that that minimum value is right around, so when it says 8.237 e to the negative 7, that's actually very, very close to 0. So it's practically 0. So it looks like that minimum value happens at 0, negative 5. So the minimum value is negative 5, and it occurs when x is very, very close to 0. Now say we want to also find the maximum value. We know it's just a little bit to the left of that minimum value. We can go through the same process, hit second, trace. This time we're looking for the maximum, so I'm going to scroll down to maximum, hit enter, and now I'm going to move the cursor until I'm definitely past that maximum value. Hit enter. Now let's give it the right boundary. So I'm going to move until I'm definitely to the right of that maximum value. Hit enter, and hit enter one more time. And we see here the maximum value happens at negative 1.3 repeating, negative 3.81 or so. So the maximum value, this local max, is at negative 3.81, and it occurs when x equals about negative 1 1/3.